Our research question is asking if there is a correlation between the structure of a galaxy and its location in relation to a galactic cluster. Although galaxies have several different classifications, we will be focusing on the two that are recorded in the Galaxy Zoo dataset, elliptical and spiral galaxies. We will test this question by using the near cluster dataset in conjunction with the galaxies identified as either elliptical or spiral to find if there is a correlation between the two. Our hypothesis is that we predict there is a correlation between galaxy structure, i.e. elliptical or spherical, and position relative to galaxy clusters. If there is a correlation between cluster proximity and galaxy type, we predict that spiral galaxies are more likely to be found near clusters than elliptical galaxies.
When comparing the graph of elliptical galaxies to the graph of spirals, the trend lines begin just below 0.9 on the y-axis. It appears that elliptical galaxies do not form near clusters as often as spiral galaxies do, which supports our hypothesis.
When comparing the graph of spiral galaxies to the graph of ellipticals, the trend line begins just above 0.9 on the y-axis. The data conveys that the closer a galaxy forms to a cluster, the more likely it is to form in a spiral pattern, which further supports our hypothesis. This is the trend line comparing these two graphs.
The graph shows the total variance of all the galaxies, spiral and elliptical, structures provided by the Galaxy Zoo dataset, and where they fall in relation to the nearest cluster. The graph shows that galaxies are much more commonly found in close proximity to galactic clusters than being isolated. The x-axis represents the distance from the nearest cluster. Data points closer to 1 on the y-axis represent spiral galactic structures. Data points closer to 0 on the y-axis represent elliptical galactic structures. In the graph, we can see that there are more dots closer to 1 on the y-axis and closer to 0 on the x-axis. This means that according to the data, more galaxies form near clusters, and that these galaxies are more likely to form in a spiral pattern rather than the elliptical pattern.
This chart shows the amount of galaxies that are not in or near a cluster. As shown in the graph, there are approximately 3 times more spiral galaxies outside of clusters than elliptical galaxies. These figures were found by filtering out the results that gave the measurement of -999 and signifying that they are not anywhere near a galactic cluster.
We carried out our analysis by using the ZooTools data to relate the near cluster distance to the type of galaxy structure, and we created scatter plots of the near cluster data and the type of galaxy structure to show the relationship between the two. These scatter plots support our hypothesis that there is a relationship between the structure and the distance of the galaxy from a cluster.
Based on our hypothesis, we predicted that there is a correlation between galaxy structure, i.e. elliptical versus spherical, and position relative to galaxy clusters. From this data, there appears to be a correlation between the near cluster distance and galaxy formation. Spiral galaxies tend to form more closely to clusters, whereas elliptical galaxies are less likely to form as closely to clusters. This leads us to one final question. What causes spirals to form more commonly than ellipticals?